Hello students, Rajiv from myetutors, and in this short episode I am discussing the common errors that you as a student commit when you are solving abnormal molecular mass numericals. So let's dive into detail to understand what are those common errors. The very first error is that in questions usually it is not mentioned that you are supposed to use abnormal molecular mass formula. Now how would you decide that either abnormal molecular mass formula is to be used or not? So a simple trick is, if you are given, say for example, first case is, if you are given a electrolyte in aqueous solution. Suppose you are given an electrolyte in an aqueous solution, then you have to use abnormal molecular mass. Now electrolyte would be like NaCl, KCl, aluminium sulfate, or any ion which can dissociate in aqueous solution. It can be acetic acid also, because it will dissociate to certain extent. So any electrolyte, either it is a strong electrolyte or it is a weak electrolyte, if it is given in aqueous solution, then you have to use the van Hoff factor I, and the formula would be respectively, if you are calculating say depression in freezing point, so delta TF would be I into KF into M, and accordingly you will calculate. If you are calculating elevation in boiling point, then it would be delta TB would be I into KB into M, and you would be using van Hoff factor. I have already explained how to calculate van Hoff factor for these electrolytes. If you are not aware, then check the description box for the link of the video in which I have described how to calculate the van Hoff factor for these electrolytes. So accordingly you can calculate the van Hoff factor and use it. So remember, when it is a aqueous solution having an electrolyte, then you have to use van Hoff factor. Now the second thing is, if you are given a non-aqueous solution, you are given a non-aqueous solvent and you are adding a polar solute having dipole, then in such a condition association is bound to take place. The examples can be like adding acetic acid in benzene or toluene or ether. So if these are solvents and acetic acid is added into it, then it would associate, and we would use the same formulas, but we would calculate for association. And if you don't know how to calculate for association, then check the description box and find the link how to calculate association of solute, and specifically it is dimerization. So this is the first basic thing that you should remember. In questions it is never given to use abnormal molecular mass or van Hoff factor directly into the questions. Now the second common mistake is that students get confused between alpha and I. These are two different things. Alpha would be percentage degree of dissociation, or association, and this is basically van Hoff factor. Now degree of dissociation is the amount of solute which gets associated or dissociated in the solution, and van Hoff factor is calculated on basis of degree of association or dissociation. and the formulas are different. For association, it is a different formula. For dissociation, it is a different formula. If you are given in a question that it is 70% dissociation or 70% association, that means that the value of alpha is given. It is not I. I have seen students directly using this value as I. It is not I. If in a question it is given that the solute is 70% dissociated or associated, that means that you are given the value of alpha, and accordingly you have to calculate Van 't Hoff factor I, and then that Van 't Hoff factor can be used in either depression in freezing point, elevation in boiling point, or osmotic pressure formula for calculation of the colligative property. So this is the second mistake that I have seen over the years that students commit. And the third mistake is a silly mistake. Now, if you are calculating, say, boiling point of solution or freezing point of solution, then you have to remember that if it is an aqueous solution, then the T1 for freezing point of water would be 0 degrees centigrade, or it is 273 Kelvin. Similarly, T1 for boiling point, that is boiling point of water, pure water, in this formula would be 100 degrees centigrade, or it is 373 Kelvin. Now, the formulas would be like this. Delta TF is T1 minus T2, and T1 is 0 degrees centigrade in case of freezing point, and delta TB would be T2 minus T1, and in this case this is 373, this is 373 Kelvin or 100 degrees centigrade, and this would be 0 degrees centigrade or 273 Kelvin. So accordingly you have to calculate, either you are calculating in degrees centigrade or in Kelvin. You will subtract the value according to the equations. So try to remember that when it is freezing point associated with aqueous solution, it is always the freezing point of water would be 0 degrees centigrade, and if it is boiling point, then the boiling point of water would be 100 degrees centigrade. So these are the common mistakes I have seen over the years. So if you think that this video has given you some better ideas for eliminating out errors that you might be committing while solving these questions, then give me a like, subscribe to my channel, and don't forget to hit the bell icon. By hitting the bell icon, the YouTube would be sending you a notification whenever such types of videos are uploaded on my channel. Comment on the comment section below, follow us on social media, and thanks for watching this video.